So properties of determinant, this one is the first one. It says the determinant of a matrix is 0. The determinant is 0 if you have these three conditions. If the matrix has a 0 row or a 0 column, if any of the row or column of a matrix happens to be 0, it means that the determinant of that matrix is 0. For another B is that if the matrix has two identical rows or column, if they have two identical rows or column, then the determinant is also 0. And the matrix number C is if a row or column is a multiple of one another. So if you can obtain another row or a column by multiplying and adding columns or just a multiple, then let me just say, give you an example for C. For example, if I have 1, 2, 4, and 3, and then let's even add, let's add another one. So let's say 3, 1, and let's make here 2, 8, and 6. Now this matrix is what? The determinant is going to be 0. Why? Because if you look at the first row and the third row, you see that this is true. You can see that row 3 is nothing but 2 row 1. So it means that one row is a multiple of the other. So this one, the determinant, you don't need to struggle. The determinant is going to be just 0. Okay. Also, like this one, it says if they have two identical rows or column. Identical means they are the same. For example, if you have 1, 2, or 1, 3, and then 1, 3. You see, this one, the determinant will be the same. Or let's say we would make it 3 by 3. Let's say you have 1, 3, 0, and then you have 3, 2, and then you have 1. Let's make this one different. 4, and then you have, let's say, 1, 3. Okay, let's do this one. Let's say 0 here, 2 here, 4 here, and then 5 and 5. So this also, the determinant will be 0. Why? Because you have two rows, two columns that are the same. Okay, right? Then this one is the first one. It says if you have identical, if you have any rows or column that are identically 0, then you know there's going to be a problem. For example, if you have a matrix, let's say 0, 0, 0, 1, 3, 4, 2, 1, 6. Now this, see the row, the first row, all 0. So it means the determinant is going to be 0. Right. Then another one is this one, which is also very popular. Finding the determinant of K. Look at the K. The K is inside the matrix. The determinant of K times A is going to be K to power N times what? The determinant of A. And where N is what? N is, let's say, the order of matrix A. So A has to be N by N. And then we have this determinant of A times B is the same thing as the determinant of A, determinant of B. The determinant of the identity matrix is equals to 1. So for example, if you take the identity matrix, let's say you take I to power 3. What is I to power 3? It's just this, right? Now, if you look at this, this is a what? This is a triangular matrix because this is the main diagonal. And you see here, every element above and below are even 0. So if you want to find the determinant of I3, it's just 1 times 1 times 1, which is equals to 1. And these are another two property. The determinant of A inverse is just what? 1 over determinant of A. And then you have also this property, determinant of A plus B is not determinant of A plus the determinant of B. All right. So let's look at these few examples. So for example 8 now, it says if A is what? A is 3 by 3 matrix. A is 3 by 3, then the determinant of A is equals to 5. You want to find this this expression. So we want to look for determinant of 2A plus 2 determinant of A minus 2 determinant of I3. So using one of the properties, remember A is 3 by 3. So if you want to bring these two out, it will come out as 2 to the power 3, then determinant of A plus 2 determinant of A minus, these 2 will come out as 2 to the power 3 determinant of I3. Why is it 2 power 3? Because the order of I3 is also 3. And what will it be? This is just going to be 8 times 5 plus 2 times 5 minus 8 times what? 1. Because 1 is the determinant of the identity matrix. Now, what do we have here? So this is just 40 plus what? 10. Just 40 plus 10 minus 8. And this is going to be 50 minus 2. 50 minus 8, I think this should be 42. Example 9, it's similar. Example 9 says the determinant of A is 5, the determinant of B is 3. A and B are order what? Order 4. So if A and B are order 4, then the matrix AB is also going to be 4 by 4. So it means this matrix is 4 by 4. So it means if this 2 is going out, it has to go out as 2 to the power 4. Then you have the determinant of AB plus 3 determinant of B. This is going to be 5 times 1 over determinant of A plus this one times, this 3 will come out, so it will be 3 to the power 2 determinant of what? Of I2. So now this 2 to the power 4 is nothing but 16. This you can break it as determinant of A times determinant of B. Then plus, let me just, I'll still repeat this one. So this will just be 5 determinant of A plus, this will be 9. So this is 45. So this is going to be 16 times what? Determinant of A is 5. Determinant of B is 3. Determinant of B is still 3. So 5 over. Determinant of A is 5. So this is 5 over 5 plus 45 times 1. Right? So this is what we have. We have 16, which is like 16 times, it's going to be 16 times 15, right? So it's going to be 16 times 15. All of this this is about 240, I think, plus 9 minus 1 plus, I think, 45, right? And these two will give us 2, this is 285 plus just 8, I think. Yeah, because you have this plus 45, which is 285, and then I think plus 8. So it's about, let's say, 293. Okay. Now let's look at other properties that are associated with what? With the properties associated with row operation. Properties associated with row operation. So this is saying if you have a matrix A and B, they have the same size. If you interchange the words, when you are doing row operation, if you interchange the row operation, let's say you interchange rows, then there will be negative. So if you perform row operation by interchanging rows, then you need to introduce negative to the determinant. The determinant will not be the same. The second condition, if you multiply a row or a column by a constant, then the new determinant, the new matrix you're going to have, you have to multiply the determinant by k. Then here, if you do this row operation, when you multiply a row by a column and then add to another row, in that case, it does not change the determinant. So we have only three basic row operation, and only two affect the determinants. Number three does not affect the determinant. The determinant will remain unchanged. But first one, which means interchanging row or column, will affect the determinant by a minus. The second one, when you multiply a row or a column by a constant, it will also affect the determinant. You have to multiply by k. But if you apply this row operation, this type, then it does not affect the determinant. So let's use this to answer example 10. So if you look at example 10, you are given that this determinant is equal to 5, right? So we want to use this to evaluate this determinant. So what that means is we have to find a way. We have to find a way to go from here to here. So let's start with this one. This is what we have: A, B, C, E, 2F, 3G, H, I, J. This determinant is what? Is minus 5. So if I want to get this, so my goal is to target this one. So I can see that I can multiply the row 1 by what? By 2. So if I multiply row 1 by 2, here will become 2A, 2B, 2C, then E, 2F, 3G, H, I, J. And that means I have to multiply this determinant by 2. So this is going to be 2 times minus 5, which is equals to minus 10. Okay. Now, another thing is, so we have to look at what we have and try to see how we can get there. So now we will do what? I want the E downstairs so I can interchange. So we can perform R2, interchange R3. So if we do that now, this means I will have row 1 remains the same. So this will become H, this will become I, this will become J, this becomes E, this becomes 2F, this becomes 3G. And because I've done this interchange, here, it means I have to multiply this by, so this is going to be minus 10 now. So the determinant is going to be 10. But we are not yet there. So what can we do? We can even multiply what? So we can multiply by what? Let's see here. I think we can go here. Now, remember, look at our target here. We want to get something like this. So now we can apply what? We can apply the row operation of what? Our target is the second row now. So we can do two. This one will remain the same, 2A, 2B. We don't want to temper it again. But this one, we can do 2 row 3, then plus what? Row 2. But we know that this type of operation does not change the determinants. So we multiply E by 2, we add it to H. So this is just going to be 2 plus H. We multiply 2F by 2, which will be 4F plus I. And we multiply 3G by 2, which is 6G plus J. Okay. And then this will still remain as E, 2F, and 3J. In this case, the determinant will still remain as 10 because we apply this row operation. So this is what we apply here. This one does not change. Okay, so these are the row operations. Then finally, we can multiply because we need a minus here. Since we need a minus, we can multiply the third row. So we're doing minus R3. And this will give us the final matrix that we want. So this is 2E plus H, 4F plus I, 6G plus J. And this is going to be what? Minus E, minus 2F, and minus what? 3J. So this is just going to be minus 10. So it means the answer, it's minus 10. All right, so I think that will be all. The next video will be solving old exam. So thank you for watching. If you have any question, put it in the comment section. You can share, subscribe, and like this video.